Now with decimals, we're going to use decimals a lot in this class, so we do have to pay close attention to the rules with decimals and the place values, especially with rounding. Some people are very shaky with place values and rounding to the nearest tenth and the hundredth, but in healthcare, oftentimes we round to the nearest tenth or to the nearest hundredth. We generally don't round to the smaller place values than that, because if we were measuring something, most of our measuring devices have calibrations which only can get accurate to the tenths place or sometimes the hundredths place. But one thing you should know about a decimal, you have a decimal point we'll write it in the middle here, and the whole number part is to the left. The ones, the tens, the hundreds, and so far. And one thing you should know is as you go to the left, the place values get larger by a factor of 10, which means as you go to the right, the place values get smaller by a factor of 10. So you notice as you go to the left, you have ones, tens, hundreds, thousands. They get larger by a factor of 10. But when we go to the right, thousands, hundreds, tens, ones, they're getting smaller. The place values themselves are getting smaller by a factor of 10. If you divide 1 by 10, you get tenths. Divide tenths by 10, you get hundredths. Divide that by 10, you get thousands. One very, very important thing in healthcare, so we don't make any errors with our dosages, whenever you have a number between 0 and 1, these are all three good examples. These are all numbers between 0 and 1. We have to include what we call the leading zero. Even if you have all the other numbers to the right correct, if you don't have that zero there, it's going to be marked wrong. Because it's very easy for someone to write 0.7, which is 7/10, down. And if they only write it as 0.7, and somehow that little point is not as clear as my point there, that 0.7, that 7/10, has automatically turned into 7. So if you were supposed to give someone 0.7 milligrams, instead you gave them 7 milligrams, that could be bad. So in order to emphasize that it's 0.7, we always put a 0 in front of that decimal point. That's called a leading zero. You notice this one here is not in the tenths, hundredths, but it's in the thousandths position. We call that 1,000th. That's the same as the fraction 1 over 1,000. So if I have 200ths, remember, tenths, hundredths. 200ths, that's the same as 2 over 100. And if you reduce that, you would get 1 over 50. So decimals can be very easily written as fractions just by dividing by the smallest place value. So 7/10 as a fraction is 7 over 10. And we've talked about the place values. These two sentences just reiterate what was on the previous slide with the place values. That the first position to the right is the tenths, the second place is the hundredths, the third place to the right of the point is the thousandths. Now when we want to compare decimals, just like we compared fractions, when we compared fractions, we said one way to do that would be to rewrite them with a common denominator and then compare their numerators. But when we're comparing decimals, we look at the digits or the numerals that are in the place values. We start on the left end of the number, though, the larger place values. So if you have these three decimals, and again, that's red, 125 thousandths, and that's 500ths, because the 5 is in the hundredths place, and 2/10. And they want us to determine the largest decimal fraction. Well, you notice all of these have a 0 in the units digit or the ones digit. So that's not going to help us decide which one is larger or not. So we go to the tenths position. This first fraction has 1/10. This has no tenths. And this has 2/10. So one has 1/10, one has 0/10, and one has 2/10. That's all we need to know because none of them are the same. So the smallest one is the one with no tenths. That would be 500ths. So that's the smallest. I'll put S for smallest. Then we write the one with the 1/10. That's the medium number. And then the one with 2/10 is the largest because 2 is greater than 1, which is greater than 0. So that's the largest. So if we were to put these in order, it would be 500, 125 thousandths, and 2/10 in that order from smallest to largest. So start at the left end of the number and work your way to the right until you break a tie. So remember, when we looked at the one digit, they all had a 0. So that wasn't going to tell us which one was smaller or larger. That's why we had to go to the next smaller place value, which was the 10th position. And this is showing you how you could do it if you converted them to fractions. What they did is they added zeros. This might not be the best way to do it, because in reality, we're never going to use a trailing 0. We said we always had to have the leading 0, but we never want to leave our answer with a trailing 0. So if you're going to write it there, remember that's not a proper way to leave a final answer. But the reason they did that is they said this is the one that had the most decimal places. So what they did is they filled in the zeros of the other ones until it was written with thousandths also. And then once they were all written as something thousandth, something thousandth, something thousandth, then they wrote it as a fraction, and then you could go back and use the method from earlier on in the chapter. Once they have the same denominator, the one with the smaller numerator is the smallest number, and the one with the largest numerator is the largest number. But all we did is probably the better way. We compared the numerals or the digits that were in the place values to decide which one is the largest. And this is reiterating what we said earlier about the zeros. That if you had 5/10, you would write it as 0.5. You would not write it as 0.5, and you would not write it as 0.50, because we don't want the trailing. We don't want the trailing 0, and we always have to have the leading 0, and that one doesn't have the leading 0 in front of to the left of the decimal point. So 0.5 is the way that we're going to write 5/10. What they're basically saying, though, is those zeros don't change the value of the number because they're all 5/10. There's a proper way to write 5/10, and that is with a leading 0. Now, you just can't throw zeros anywhere. Like if I had 0.05, that's not the same as those numbers, because this number is not 5/10, that's 5/100, which is 10 times smaller. And that's what this point is reiterating. So zeros added before or after the decimal point do change the value. So you notice how they slipped the 0 in there? So instead of being 1 and 5/10, and that's how we would read that, 1.5 or 1 and 5/10, you can't just put a 0 in the middle of the number, because then it's not 1 and 5/10, it's 1 and 500. It's 1 and 500. And you can't just throw a 0 to the left of the decimal point after the 1 either, because 1 and 5/10 is not the same as 10 and 5/10. So you have to be careful with your zeros. Maybe one of the most important things in this part of the chapter, always place a 0 to the left of the decimal point. Never leave it as 0.2. Always write it as 0.2. You have to have that leading 0 if a decimal is between 0 and 1. Because the first way how I wrote 0.2, which is 2/10, if something happened to that little decimal point, and someone didn't write it real clearly, that 2/10 has all of a sudden turned into the number 2, which is 10 times its value, which could be harmful to a patient. So we always place a 0 to the left of the decimal point if the number is between 0 and 1. Same thing, reiterating that point over and over because it is such an important point. We would not leave it like that. We would write it as 0.5 if we wanted 5/10. It will be marked wrong if you don't have the 0 out in front. Even if you have the 5 correct, if you don't have the 0 there, you'll be wrong. In this class, you are allowed to use your calculator, even on tests. So as long as it's a non-graphing calculator, if it's just a basic scientific calculator, you can use it on your test, your 3 tests in this class. And so, in other words, when you're dealing with decimals, it is okay to use your calculator as a check. But you might not always have a calculator. For example, on some of your tests to get in the nursing program, you may not be allowed to have a calculator, and that's why we'll quickly go over how to add and subtract decimals by hand. On your calculator, you just punch it in and push equals, and it will do it for you. So if I were adding two fractions, we do want to line them up vertically and align the decimal points. So if I had 0.612, which is 612 thousandths, and I have 0.94, and I'm adding. We want to align the decimal points, which I already have did. When I wrote it down, I aligned the decimal points and add zeros at the end if needed. If it helps you, you can add a zero to the right. Just remember, we're never going to leave that in our final answer, a trailing zero to the right. So we're making all the decimals, you can think of the same length by doing that. And then what we do is we add from the right to the left and carry if we have to. So 2 plus 0 is 2, 4 plus 1 is 5. We want to bring down the decimal point. 9 plus 6 is 15, so we write the 5, carry the 1, 0, 0, 1, add it to be 1. So our answer would be 1 and 552 thousandths. Now in some problems it will say add, and at the end round to the nearest tenth. I think rounding is coming up, but we'll get ahead. If it said round to the nearest tenth, this is the tenth position. It says round to the nearest tenth. We look to the right. If the digit to the right is a 5 through 9, we come back and we round up and then get rid of the digits to the right of that. So if it said round to the nearest tenth, our answer would be 1.6. If it said round to the nearest hundredth, we would look to the right of the hundredth digit, and since it's a 2, it's a 0 through 4. That means we come back and we leave the 5 as a 5 and just get rid of the digits to the right of that. So it would be 1.55, which is 1 and 55 hundredths. So again, this one would be our answer if it said round to the nearest tenth. This would be our answer if it said round to the nearest hundredth. So tenth means 1 decimal place. Hundredth means you should have 2. Multiply and divide decimals. When we multiply and divide decimals, that's going to be crucial, especially when we're converting in chapters 3 and 4, especially with the metric system, because in the metric system we multiply by powers of 10 and divide by powers of 10. So multiplication and division is going to play crucial once we get to chapters 3 and 4 and beyond. Now, the key thing about multiplication, I would still probably line them up vertically. So if I had 2.6, 2 and 6 tenths, times 0.12, 12 hundredths, if I was asked to multiply that, I would multiply as I normally would, but with disregard to the decimal point initially. And then at the end, we're going to put the decimal point in the correct place. So if we multiply this as we normally would, if I go 2 times 6, that's 12, carry the 1. 2 times 2 is 4, plus that 1 is 5. Now, when I move over to the 1 here, 1 is in a bigger place value, so I'm going to move over 1 place. You might want to put a 0 there. 1 times 6 is 6. 1 times 2 is 2. And then 0 times anything is just going to be 0, so we can skip doing that. And then we add. And we get 2, 11, carry the 1, and you get 3. 3, 1, 2. Now we have to know the proper place to put that decimal or decimal point. And what we do is we count the total number of characters or digits to the right of the decimal, how many places we have. So we have 1 decimal place there and 2 decimal places there. We add the total number of decimal places, and we have 3. So from the right, we come in 1, 2, 3 places and put the decimal right there, decimal point there. We always have to put that leading 0, though, so it'd be 0.312. That kind of makes sense if you're halfway decent with numbers. 12 hundredths is about 1/10. That's in the neighborhood of 1/10. So we're basically taking a tenth of 2.6. And a tenth of 2.6 would be around 0.26 to more than 1/10 of 2.6. So it should be a little bit more than 0.26, which it is a little bit more than 0.26. So we have to put that 0 out in front. Again, you could check that on your calculator if you would like to. Now, when we divide decimals, we do it longhand. Some people call this long division. So if I was to take 8.6 and divide it by 1.4, what we would do, the divisor, the second number, we'd write out in front, 1.4. The dividend is what we're dividing into, is 8.6. It's much easier to divide by a whole number, so we're going to make the divisor 1.4 into a whole number. In effect, what we're doing is just multiplying the first fraction we had by 10 over 10, because this is really 8.6 over 1.4, and we want the denominator to be a whole number, so we're just multiplying by 10 over 10. We're multiplying by a form of 1. What that does is when you multiply by 10, it moves the decimal point to the right one place. Bring that decimal point up in your answer, which is called the quotient. And now we're dividing by 14, which is a lot easier. Now 14 does not go into 8, so if you want to put a 0 above the 8, you could. I'll just leave it blank. But 14 does go into 86. I believe it goes in there 6 times. So if we multiply the divisor 14 by 6, we get 24. Carry the 2. 6 times 1 is 6, plus that 2 is 84. And we subtract. When we subtract, we get a 2. 86 take away 84 is 2. And then we bring down the next digit, which we have zeros there. We can bring it down as many as we need to, depending on how accurate we want our answer. So we bring down the next digit, which is a 0, start all over again. How many times does 14 go into 20? One whole time. So 1 times 14 is 14. If you subtract, you get a 6. Bring down the next digit, which is a 0. How many times does 14 go into 60? That's only going to be 4 times, because 4 times 14, I believe, is 56. You subtract, you get a 4. Bring down the next digit, another 0. How many times does 14 go into 40? I think only 2 times, because 2 times 14 is 28, and when you subtract, you get 12. So you could keep on going. That's how you divide decimals. Now, if it said round to the nearest tenth, you would need to know what the hundredth digit is, so to round up or down. If it said round to the nearest hundredth, you would have to go to the thousandth position in order to know whether to round the 4 up or down. So if it said round this to the nearest tenth, round to the nearest tenth, our answer would be 6.1. Nearest tenth. So we look to the hundredths place. It's only a 4, so we come back to the 1 and leave it and get rid of the 4 too. So again, on your calculator you can divide that, but you should know how to divide in case you're not allowed to have a calculator on one of your assessments. But in this class, all 3 tests, you can use a non-graphing calculator. Well, as I was saying, it's very helpful to know how to multiply by 10 and divide by 10, especially when we're working with a metric system in chapters 3 and 4. If I had 6.32, 6 and 32 hundredths, and when you times that by 10, the decimal point will move to the right. So that's just 63.2. Which means if I had 6.32 and times it by 2 factors of 10, which is 100, the decimal point will go 2 places to the right, so that's 632. Now when you divide, the decimal point will go to the left. So if I had 57.6 and I divide that by 10, the decimal point will go to the left 1 place for each factor of 10 that you divide by. So that's 5.76. So if I have 57.6 again and I divide it by 100 this time, the decimal point will go 2 places to the left, which would give me 0.576. You have to have that leading 0 since now we have a number, a decimal between 0 and 1. Again, that's going to be very helpful when we convert within the metric system. And here are just some examples. You have 5.06, 5 and 600ths times by 10. When you times by 10, decimal point will go to the right, so it's 50.6. But when you divide by 100, you're really dividing by 2 tens. So the decimal point will go 2 places to the left. So the decimal point will go right there. So you need a 0 there and always a leading 0. Just a few more examples. Rounding decimals, I think we've talked a lot about rounding decimals. You have to know your place values. So if it says round to 1 decimal place, that means you're rounding to the nearest tenth. If it says round to the nearest hundredth, you're rounding to the second decimal place. So in here it says round to the hundredths, which means 2 decimal places. So if it says round to the hundredths, you need to look at that digit that's in the thousandths position, and that will help you to determine whether you're rounding up or down. And since that's only a 3, you're going to get rid of it and leave the 2 as your hundredths digit. Since this one is a 4, you're going to get rid of it and leave the 4 as the hundredths digit. Since the thousandths digit is a 5, you're going to go over here to the hundredths digit and what we say round up. You're going to make it bigger. Instead of a 3, you're going to change it to a 4, and then you're going to get rid of the thousandths digit. Here, the thousandths digit is a 6, so that's between a 5 and a 9. So you're going to go back to your hundredths digit and round up to a 7, and then get rid of all the other positions to the right of that. So make sure you know how to round, but also you notice if a decimal is between 0 and 1, you have to have that leading 0. I think this is the last slide. And this is just extra rounding, because remember we said, usually in this class we're going to round to the nearest tenth and hundredth, hardly ever to the thousandths position. Same rounding rules apply. If you're rounding to the nearest tenth, as it says to over here, the hundredths digit, whatever numerals in the hundredths digit, that's going to be the deciding factor. So since the hundredths digit here is a 3, that's between a 0 and a 4, so we leave the 1 as the tenths digit. Here, the hundredths digit is a 4, which is between 0 and 4, so we're going to leave the 6 as the tenths digit. This hundredths digit is a 5, that's between 5 and 9 inclusively, so we're going to round the 7 up to an 8. This is a 6, so we're going to round the tenths digit up to a 7. Here, this is a very good problem here to end on. The hundredths digit is a 5. So we're going to go to the tenths digit and round up. But after 9 tenths is 10 tenths. 10 tenths means it's 1. But we're not going to write it as 1.0. Even if it tells us to round to the nearest tenth, we're not going to round it as 1.0 because we never use trailing 0. So we're going to leave our answer as 1. That is rounded correctly to the nearest tenth, because the hundredths digit was a 5, so we rounded the tenths digit up. Above 9 is 10. 10 tenths is 1.0, but we're not going to include the 0 as our tenths position because we do not write trailing zeros. So our answer is just the number 1. And that is a very quick overview of all of Chapter 1, which deals with fractions and decimals. Please make sure you read all the material in your textbook in Chapter 1 and complete all the problems that are assigned in the textbook and check your answers.